nanoparticles, networks of atoms that are so small they can move through the human body without any issues. Inadvertently when we breathe in fine dust, and deliberately when we ingest drugs that are prepared with nanoparticles. Yet since when are human beings able to enter into the tiny world of nanoparticles? In general, we assume that the nano world began when we were able to see it, for instance with the electron microscope. However, I believe that especially in medical science, the nano world began much earlier. For example, during the use of liquid gold. This gold in water was used for all kinds of therapies. Back then we didn't know that the gold is nanoparticles and looks like these ones here, so it's actually red. However, we knew that it could help with rheumatic pain, for example. The way nano gold works is very fascinating. We utilize its ability to camouflage. The gold is coated with ligands on the surface and becomes invisible in the bloodstream to the immune system. With this camouflage, you can now enter a target area and mark it or systematically destroy the area with radiation.
Dann diesen Ort gezielt zerstören.
There is far more nanotechnology and medical technology than one would expect. There is the anti-infective coating of medical devices, for instance, all the way to implants. At least as exciting, though, are implant surface coatings. Let's take a cardiac pacemaker, or rather the cardiac pacemaker electrodes, for example. It is well known that they have to adhere particularly well, and that's a problem to this day. However, if you equip those electrodes with nano-abrasiveness, it has been shown that the wanted cell type can attach there particularly well. This is important for the communication between the implant and the nervous system and the cardiac muscle cells, respectively. To ensure that the surface structure of an implant is biocompatible, it has to be painstakingly checked, also all the way down to the Nano Dimension. Jürgen Valentin from the Nanofocus Corporation explains which surfaces his company's equipment can measure and how safe the results are.
Die Palette reicht von Implantaten, von
Our lineup ranges from implants, high-polished joint sockets, up to dental implants that are very rough on the surface.
Zunächst die dreidimensionale Gestalt und Struktur der Oberfläche.
At first, we measure the three-dimensional shape and structure of the surface. Based on this data, we can calculate different characteristics, like, for instance, abrasiveness, which is a measure for the height fluctuation on the surface. With this system, you can measure height differences down to the nanometer area. That is to say, and to name an example, even the most subtle tool marks and scratches can be made visible and measurable on high-polished hip joints. The most important thing is that this is also reproducible and very robust. That is to say, repeated measurements always show the same clear result. The standard practice is to check and secure the accuracy of this process by means of calibrated normals. The Physical Technical Federal Institute certifies these normals, and we, the manufacturers, use this in our product acceptance tests, and our customers use it for their regular quality control. One measurement run only takes a few seconds, does not require sample preparation, and can be used in line during production. Another step towards a future where a world without nanotechnology can no longer be imagined. However, the question is how we want to handle this new technology. There is a whole number of regulations that need to be adhered to, of course, when you manufacture implants. That is why people agree that the existing guidelines generally suffice, because they are specifically designed for an application. Nanotechnologies are therefore well monitored and are generally safe. Where does the trend go next, though? Personally, I see a very strong trend toward intelligent materials, not towards the pure platinum nanoparticles or pure gold. That is to say, the trend goes towards functionalized nanomaterials and functionalized nanoparticles.
Dimension.